This is Advanced Math, Unit 8, Lesson 7A. Inverse functions. Okay. Definition. First, two functions f and g are inverse functions if and only if you remember that it's not if, it's if and only if. You learned that well, last year before, at least the shorthand notation. Two functions f and g are inverse functions if and only if f of g of x equals x and g of f of x also equals x. When you do a composition, you learned composition last year, around this time last year you were working with compositions. F of g of x, if you plug g into the f function, it gives you x. If you plug f into the g function, it equals x. Now this if and only if means f and g are inverse functions if this happens, and if this happens, that means f is an inverse function. It goes both ways. Okay. For every x in their domain. So it doesn't only work for some, it works for all the x values in their domain. Always and forever. Okay. You've assuming seen that notation. Yes, you've seen that notation when we did inverse sine and inverse cosine. That little negative symbol there means f inverse, or the inverse of f. F inverse, or the inverse of f. All right, so that little -1 symbol. That's why we used to write sine -1, cosine -1, meaning the inverse function. It's what we called it. Okay, so what this means, if I have a function f of x, and over here I'm going to write the function f inverse of x. And here I'm just going to make a t-chart. I'm going to call this my domain, and this my range. And if my points were 1, 3, 2, 4, and -3, 5. These are just numbers, random numbers I've picked. It's nothing, not a special function. It's just if I had these three numbers in my f of x function, my domain range, x and y values, then the inverse function, what's really nice about it is that it flips around. Domain, range. The range becomes the domain, 3, 4, 5, and the range becomes, domain becomes the range over here, 1, 2, -3. So this domain becomes the range, this range becomes that domain. They just pretty much flip-flop over. And it's always going to happen if they are inverse functions. So if they ask you, if they give you the f function, f of x, and they ask you to find the domain of its inverse, all you have to do is find the range of the original function. It'll be the domain of the inverse. I'll talk more about that. I know it's kind of hard when you don't see a problem. We will talk more as we go. Okay, key information. A function and its inverse are reflected across the line y equals x, period. A function must be 1-to-1. That's the way I'm going to write 1-to-1, 1-1, must be 1-to-1 to have an inverse. And I'll show you what that means in just a bit. To have an inverse. So, not all functions have an inverse. They have to be 1 to 1. Okay, what does that mean? I'm going to draw a picture here. Let's make our graph. Now, I'm going to draw a parabola, and I'm going to erase half of the parabola. So if you're drawing in pen, don't draw this whole piece yet, because again, I will be erasing some of it. All right, so a regular parabola. And actually, I'm going to, I'll just put it here, 1, 2. Let's say that's positive 2. It went up to y equals x squared plus 2. Okay, so when you have that function, you do the vertical line test. That's what we learned, you learned last year, but we reviewed again the other day. Vertical line test to test if it is a function, and it is. It passes the vertical line test. Now, to test it for a 1-to-1 function, you do what's called the horizontal line test. Horizontal line test. Now, it has to pass the horizontal line test in order to have an inverse. And you can see that this parabola does not pass the horizontal line test. If I were to draw a horizontal line, it would cross my parabola more than once. Okay, so just like the vertical line test could only touch a graph once, same thing with the horizontal line test. So this parabola is a function. It passes the vertical line test. It is a function, but it is not a 1-to-1 function because it does not pass the horizontal line test. So that's what I was saying earlier. Have an inverse. If I gave you a function like this, this passes the vertical line test. It is a function, and it also passes the horizontal line test, so it is a 1-to-1 function, which means it does have an inverse. And we'll work more with that on 8.7b notes with the graph. Okay, so back to the parabola. It is a function, but it's not 1-to-1. So in order to make it 1-to-1, you will typically see only half of the parabola, whether it's the right half or the left half, it doesn't matter. So I'm just going to do the right half of that parabola. Now, it still passes the vertical line test, but because I've erased the other half, it now passes the horizontal line test as well. So now this is a 1-to-1 function. Okay, so what was this about? The inverses are reflected across the line y equals x. Remember the line y equals x. I'm just going to draw a dotted line here to represent that. Y equals x has a y-intercept of 0 and a slope of 1. So if I were to go here and go up 1 over 1, up 1 over 1, or down 1 over 1, I'd end up with this line going right through the origin. Okay, so remember what I said earlier about the points being flipped around. If this ordered pair here is 0, 2, its inverse would have the point 2, 0. Oh. Okay, because you flip the 0, 2 around and 2, 0. Now, it's reflective across this line, so you kind of mirror image it. Imagine this flopped over. Again, we will get more practice with this on the 7b part of notes. We'll actually plot points and get the real graph. Right now, I'm just giving you like a rough example of what it looks like. But again, we will graph it on graph paper. Okay, so that's what the original function f of x would look like. And this is what f inverse of x would look like. All right, so I'm going to give you steps on how to find the inverse. How to find the inverse algebraically. Step 1, change f of x to y. Step 2, swap your variables. And step 3, solve for y. And I'll go ahead and put 4 in there. Change y to f inverse of x, or g or h, whatever letter you may be using. Okay, so this is how to find the inverse algebraically. How to find the inverse algebraically. Okay, let's go ahead and try some examples. Number 1, find the inverse of f of x verify that f of f inverse of x equals x and f inverse of f of x equals x. All right. And here is the function. F of x equals 2x minus 1. Okay, step 1, change f of x to y. Y equals 2x minus 1. Step 2, swap your x and your y. This becomes x, this becomes 2y minus 1. Next step, you solve for y, so you add your 1 over, and then divide everything by 2. And I'm going to move it over this way. Y equals x plus 1 over 2. And that's pretty much it. All we have left to do is swap out the y to f inverse of x equals x plus 1 over 2. Now I haven't done this verify piece yet, but this is the first part of my answer. And it's pretty simple. You just swap the variables, solve for y, put in the f inverse, and you're done. Now some people might write this as x over 2 separated plus 1 over 2, perfectly fine, or 1/2 x plus 1/2. Up to you and how you want to write it. Okay, so over here on this other side, I'm going to do the verify piece. I have 2 of them to do. I'm going to do this one first, and it doesn't matter which one you do first. Verify that f of f inverse of x equals x. Okay, so I'm going to verify that f of f inverse of x equals x. I know that's pretty wordy. Okay, so here's what I'm going to do. F of my inverse function is what's on the inside, and this right here is my inverse function, x plus 1 over 2. That's the first thing I do. Leave the f as it is, and where f inverse of x is, I'm going to actually write my inverse function. Then I'm going to take this function and plug it into my f function where all the x's used to be. Where's my original x function, my original f? So f of x equals 2 blank minus 1. And I'm going to erase this f of x because I've changed it to f of x plus 1 over 2. Okay, so it equals 2 blank minus 1. I'm getting that from here, 2x minus 1. That's what my original f function is, 2x minus 1, and in the blank where the parentheses used to be, I'm going to plug in the x plus 1. All right, and we multiply. The 2's reduce, leaving me with x plus 1 minus 1, which leaves me with x, which is what we were trying to get. All right, now we are going to verify f inverse of f of x equals x. We're going both ways, and that's what you have to do when it asks you to verify. Okay, so this time I'm writing f inverse of what goes inside this time What goes inside is my f of x function, 2x minus 1, which means I'm taking the 2x minus 1 function and plugging it into my f inverse function. Here's my f inverse function. It is, I'm sorry, pointing to the wrong one. Here's my f inverse function. X plus 1 over 2, blank plus 1 over 2. F inverse is x plus 1 over 2, blank plus 1 over 2, and I told you guys about putting blanks in for your x's on a different lesson. Okay, so where the x used to be, I'm going to plug in this 2x minus 1 and simplify. There's nothing to distribute, so I can drop the parentheses. 2x minus 1 plus 1 over 2. The 1's cross out. I have 2x over 2. The 2's reduce, leaving me with x, which is what I was trying to end up with all along. All right, here's the original function. You found the inverse. You verified that when you compose the functions either way, f of f inverse or f inverse of f, you get x every single time. All right. Let's try another one. F of x equals x cubed plus 1. And we're going to do the same thing we did on number 1. So I'm just going to erase that and put the 1 down here. Okay, so find the inverse of f of x. I'm sorry, I did put it in the wrong spot. And verify. That is going to go for this one and this one. Okay. I'm going to go through this a little quicker. We swap, first change y equals x cubed plus 1, and then swap x equals y cubed plus 1, and then solve minus the 1 over, cube root both sides. Again, tomorrow we will, or our next lesson, we will be graphing these. The cube roots and the cube undo each other. Y equals the cube root of x minus 1. I'm going to swap it out for f inverse of x equals the cube root of x minus 1. F inverse of x equals the cube root of x minus 1. Okay. Now we're going to verify that f of f inverse of x equals x. Okay. So again, I'm going to take the f and leave it as f. The f inverse, I'm actually going to write down what the f inverse function is. The cube root of x minus 1. And I'm going to take the cube root of x minus 1 and plug it into my f function. My f function is blank cubed plus 1. And this here is what I'm going to plug in to the blank. The cube root of x minus 1. Again, whatever's in the parentheses, that's how you evaluate. You plug it into the original f function, blank cube plus 1, and then the cube root and the cube undo each other. X minus 1 plus 1. Those undo each other, equals x. And that's what we were trying to verify. All right, the last verify piece for this problem, we're going to verify the other way, f inverse of f of x. We want to verify that it equals x. So this time you write your f inverse, f negative 1, and you leave it like that, of, and now I'm going to plug in my f of x function, which, where is it at? Right there, x cubed plus 1. Now this time I'm taking x cubed plus 1 and plugging it in for all the x's in the f inverse function. Okay, so f inverse, where is it at, is here. The cube root of blank minus 1. The cube root of x minus 1, I just put a blank where the x used to be. And where the x used to be, I'm going to plug in x cubed plus 1. There's nothing to distribute to those into the parentheses, so I'm going to drop it. X cubed plus 1 minus 1. The 1's undo each other, leaving me with the cube root of x cubed. The cube root and the cubed undo each other, leaving me with x, again, which is what I was trying to verify. Okay, I still have a few more problems to do, but that's it for those types, and those are the ones that do take a little bit longer. So these other ones will go quicker. Show that f and g are inverse functions. Algebraically. All right. F of x equals the square root of x minus 7, and g of x equals x squared plus 7. Show, such that x is greater than or equal to 0. And I'm going to change that to a 7. Okay. So all you have to do on this one is find the inverse of the original and check if it equals g of x. Technically, you can find the inverse of g and check that it is the same as f. It doesn't matter which one you pick. I'm just going to pick the first one first. All right, it's the steps. Change it to y, and then swap your variables, and then solve for y. And I'm hoping we all know that we would square both sides in order to solve. X squared equals y minus 7. Add your 7 to the other side. Y equals x squared plus 7. Change it to f inverse of x equals x squared plus 7. And it's asking you to verify or to show algebraically that f and g are inverses of each other. Here's f inverse, and is it the same as the g function? It is, so you've proven that f and g are inverse functions. So all you have to do is pick one. It doesn't matter which one. I just picked the first one. Find its inverse and verify that it equals the other function they gave you. And that's all you have to do on those. That's it for this lesson.